Hello, can everyone hear me? Okay, thank you. So I'll start now. Hi everyone. Welcome to the Seaborn and Matplotlib Workshop. I'm Cynthia and I'm a JC1 in RV this year. And then here with me is Weezen, and we'll be teaching you guys about Seaborn and Matplotlib today. Sorry, my throat. So we'll be introducing to you like Matplotlib and Seaborn first. Then I'll be teaching you guys about Matplotlib. And then Weezen will be teaching you guys Seaborn, like after I tell you guys about Matplotlib. So what is Seaborn and Matplotlib? First, we got to talk a little bit about data science. So this is the data science life cycle. And what we'll be focusing on is data exploration and data visualization today. So first, a little bit more about data visualization and data exploration. So why is data visualization important? Well, data visualization is important because it transforms complex data into easily understandable visuals, enabling a quick identification of patterns and patterns, trends, and insights, ultimately aiding in better decision-making and communication. And data exploration is crucial because it allows analysts to gain a deep understanding of a data set, identify patterns and anomalies, and inform the selection of appropriate analysis methods, ultimately leading to more accurate and insightful conclusions. So how do we visualize data? We'll be using Seaborn and Matplotlib to visualize our data today. So Matplotlib, which is what I'll be covering, is very customizable but slightly more complicated and verbose. While Seaborn is less customizable, but it's speedy and easy to use. So now I'll be talking to you guys about Matplotlib. First, I want you guys to open up. Does everyone have access to the Jupyter notebook for like participants? Like if so, I think there's a line of code, like the very first line that says like loading relevant that helps you load your relevant dependencies. So I'd like you guys to do this first. Give like 3 minutes maybe for everyone to load this. Can they react? Okay, I'll assume like everyone's done because it's just one line of code. Okay. Now I'll be teaching the different types of figures and plots. Okay. So I can't teach you guys everything. So there'll be some resources at the end which you guys can refer to in case like I've gone too fast or you didn't understand anything. So let's take a look at this plot, okay? So this is like the basic anatomy of a graph. We've got the x-axis, the y-axis, the x label, y label, ticks, the legend, the title, the line, all this. Don't you notice that it's a little bit similar to what you guys plot in school? Like you have the line and the axis and everything. Yeah. Okay. Now on to graph types. So these are some examples of like graphs. We've got line graph, scatter, bar, stem, this kind of plot. And I've got histogram, all these, and pie chart. But okay, I'll only be covering line, scatter, bar, and pie chart because the rest are not so applicable in like most situations. And I'll only be covering line and scatter in more detail because these two, I believe, are more important and more applicable in situations where you gotta plot graphs. So on your Google Colab now, I want you guys to run this line of code, which will load your CI's data set for the like visualization. I am gonna use this data.drop now, which is a pandas function, but This is not Pandas workshop, so I'm not gonna go through what it does. It just cleans your data set. I'll give everyone a little bit of time to run this, then I'll proceed. Okay, there's the next line of code that's under this is supposed to split your data set into two. And again, this isn't a Pandas workshop, so what this does is just split it into two. I'm not going to detail about what this does. Just run it. Think. And I'll give a little bit of time for everyone to run this again before I proceed. So I'll assume that everyone's done and I'll proceed. So onto plotting line graphs. So this will be how you plot a basic line graph. So x will be your x values, y will be your y values, and then plt.plot xy will just plot the graph for you. And then plt.title just gives your graph a title, which will show on the screen. plt.xlabel and plt.ylabel just labels your x-axis and y-axis. And plt.show will show the plot for you. So your output will look something like this. I believe this code is in the collab as well. You can just run it to see for yourself. But this is what it will look like. A very nice, simple line graph. Yes. So I'll give everyone a little bit of time to run and process it, then I'll move on. So this, what I'm showing here is like the basic what your line graph is supposed to look like when you type in the collab. It's just plt.plot x1, y1, x2, y2, and then the rest of your arguments. So this is how you plot line graph. And then I use the CI's data set. I do this, which is December DF is x1, December DF other extent is y1, June DF is the June DF date is x2, and June DF extent is y2, which is basically like just now, like x1, y1, x2, y2. So this is for multi-line. This is one line, and this is another line. And then plt.show will show the plot. So when you run this code, like this is what you'll get, which is two lines, which looks quite which looks really nice. Yes. Give you guys a little bit of time to run this as well. And there's a this is only method one to plot. There's a second method as well, but that'll be after this. I've got a question. So what if there isn't plt.show? If there isn't, it will still work in the collab, but it may not be backwards compatible with older versions. So it's just better to have it so that your graph will show. And now this is method two of plotting multi-line, which is, I prefer this method because it's a little more organized. You separate both lines and you won't really get confused. So this is plt.plot December DF and then plt.plot June DF. This is x1, y1, x2, y2. And it will do the same thing as just now. So will the output change? No, it won't. It looks the same. Yeah. Now onto title, x label, and y label. So plt.title just gives your plot the title, plt.x label labels your x-axis, and plt.y label labels your y-axis. And I'll use the CI's data again, so I'll only be plotting the December DF. So I add a title, which is CI's extent over time, and then I label the x-axis as date and the y-axis as extent. And I show the plot, which will give me this. So I think all of this should be in the collab. So I'll let you run this. I'll give you a little bit of time to run this as well before I move on. And this is the graph in a larger scale, just in case you couldn't see it, or if the labels were too small. Now onto x lim and y lim. So this is how you would set your x limit and y limit, which is x lim left right and y lim top bottom. This will determine your max y value and your max x value. So oh sorry, I will live demo this part for you because it's gonna cause the entire notebook to crash. That's why it's not in the participants Jupyter in the collab. So for this, I set plt.ylim as 1315. I'll live demo it for you. And you can think about why it's not gonna, like, nothing happens. Hold on. Give me a few seconds to set it up. So you see this code. Okay, when I run it, right? Like, why isn't it setting my y limit and x limit to 1315? And when I run this corrected code, it crashes and it doesn't help because I've set this as a list and now it can't like set the y lim anymore. So that's why I didn't put this in the participants notebook. And I will go back to the slides. Give me a second. Okay, so why didn't anything happen? It's because ylim is a function and not a property you can assign. So when you write plt.ylim as 1315, I'm just overwriting the function with a list, which has no effect, and it will even cause the entire program to crash. And I have to restart the entire instance just for me to do this. So for the correct code, you will use, as you saw just now, you use plt.ylim bottom top to set the limits. And this is what it will look like. So as you can see, everything else remains the same. Oh, ignore the sign. But it's plt.ylim 1315, which will give you this, which is correct. Because I set the limit of, like, the smallest y is 13, the largest y is 15. So I cut the graph off at 13, and it will only show this part, like from 13 onwards. Now on to y ticks and x ticks. This will be this is method 1 of showing ticks, which is just plt.y ticks and then a list and then your numbers, and then plt.x ticks and same thing. Oh, what this does, right, is I'll use the data set to visualize again. So I have plt.y ticks 1315 again, and plt.x ticks 1980 and 2014. And what this does is it only shows the ticks that I put in the list. So I only want to show 1315, so it will only show 1315. And I only want to show 1980, and then it shows, and 2014, then it will only show these two. I'll give you guys some time to run this as well, because this is in the collab. And then this is method 2 of setting your y-ticks and x-ticks, which is plt.y-ticks range start stop step, and then plt.x-ticks, and same thing. This is to like just have a range of ticks appear instead of just two numbers, which is which is gonna look something like this. So I set the range to 10, 16, 2, which is what I want the y ticks to range from. So it starts from 10, and the maximum is 16, and then it skips by 2. So 10, 12, 14. There is no 16 because the max value of this graph does not contain 16, so it'll just go up to 14. But this is a more effective way of showing ranges because you don't have to type everything out. I mean, ticks, sorry. Okay, I'll give you guys a little bit of time to run this as well. Then now, under it, there's something on graph sizing, which is how you would change the size of your graph. When creating plots using Matplotlib, you'll get a default figure size of 6.4 inches for the width and 4.8 inches for the height. So DPI in this code is pixels per inch, and 300 is the recommended. And the higher value of DPI is will mean that your graph is less pixelated. So I've got two lines of code, not two lines, two blocks. One line that says without sizing and another line that says with sizing. So I want you guys to run that. There's the first line, I think I've placed sizing like below. Hold on. Yeah. So under the first graph without sizing, there's a line that says like, why isn't it like I've put plt.figure under plt.show. So I like you guys to have like maybe 2 minutes to wonder why it's not resizing. You can run both codes while you're at it. Hold on. Okay. It's not resizing because I've placed plt.figure underneath of show, which is like after show runs, so plt.figure wouldn't actually take effect. So the corrected code under it with resizing, can run that now, is when plt.figure is right under my x and y values, which will which will have an effect. Your graph will be shrunk down, I think. It just looks really big, but the graph is actually quite small. And you can compare it yourself on the notebook, on the collab, sorry. And you'll see that there's actually quite a visible difference when you do that. So I'll give you guys a little bit of time, then I will move on. Okay, now on to annotating. So this is how you would annotate a line, like a specific point on your graph. So plt.annotate text. Text is the like what you want to display, which is like maybe max point, min point, for example. XY is the coordinate that you're annotating. XY text is the text that you're gonna put over your coordinate. And then arrow props is the arrow properties which you want your arrow to have. And then the rest is just other arguments. So arrow props is a dictionary. So I hope you guys like have a recap. If Python Workshop went through this, I hope you guys know what a dictionary is now. So for arrow props, here are some of the properties. So we've got the width is the width of the arrow and points. The hit width, which is the width of the base of the arrow. Hit length is the length of the arrowhead. And shrink will shrink the arrow from, yeah. And then this is just any other arrow property, which I will provide at the end of my presentation. There are like many, I think. So I use this data set to visualize again. You see this really long, scary block of code. We're only gonna focus on annotate and this. So first, what this does is it finds the coordinates of your maximum point. So I'm not gonna explain this because, again, I'm not conducting a Pandas workshop. I think this is Pandas, yeah. But just know that it finds your max point coordinates for you. Just locates them. Okay. Then more importantly is plt.annotate, which is this, which is sorry, this is the text, which is your max extend. XY is my max extend coordinates. And then XY text is where the text would go, like position of the text, which in this case is at max date and then above max extend by 0.5. And then arrow props, here I've set the face color to green, arrow style to here, and connection style angle 3, which is how like you would connect the arrow to the point. If not, it would just default to a straight line. So if you want some funny curved arrow, you can just do this. So these are some more arguments for arrow, but like have fun looking through because I can't cover everything. So here's the code again. And then I'll let you guys look at it for a while. It's also on your collab, so you can look at it yourself actually. So this is what it will look like. So you see the max extent, like arrow, and then it's pointing at the maximum point, which is the maximum extent of sea ice over time. In this case is here. Okay, I'll let you guys run this yourself as well. I'll give you guys a little bit of time before I move on. Okay, on to the next. So take a look at this slide. You see the two lines, right? It's a little bit hard to track, right? Because you don't know which one is December and which one is June. And how we solve this problem is with legends. So this is method 1 of adding a legend, which is plt.plot. Okay, sorry, this was meant to be in legend. bbox_2_anchor goes in legend, and this would, like, as you can see here, this would put your legend outside of the graph, which is what I'd prefer, because in this case, as you can see here, the graph extends quite a bit. So if I put like the legend inside of the graph, it might obstruct parts of my graph. So what I do is I put it outside. And this is what it will look like. So bbox.anchor, I think what it does is it will put it outside, like the fraction. I have the definition. Okay, and this is like a zoom, like this is a bigger version of the graph, just in case just now someone was a little bit too small for you. Then this is method 2. So plt.legend labels. Labels is a list, by the way, which is just what your lines are. And then bbox.anchor, bbox2anchor, and then the location of the legend. So bbox.anchor, this is how it works. It will position it outside of the like graph. And then the coordinates inside will be like representing a fraction of the figure size. So I think it's just the size of the box. Then the location will specify which part of the legend or annotation box like corresponds to the XY point defined. So if you specify location equals upper left, the upper left corner of the legend box will be anchored at the XY coordinates. So these are some of the like location codes for your location. So it's like if you don't want to type upper right, upper left, just got 1, 2. So sorry, you can look at this for a little bit first before I move on. See all the location codes. If not, it would just default to best, I believe. Either that or it defaults to upper right. Okay, so using the CI's dataset to visualize, see the legend part, plt.legend December and June, which is the 2 different lines. Then bbox.anchor, I'll anchor it outside of the graph. And location is 2 because I want to put it at my upper left, I think. Oh, never mind. Doesn't have any effect. Okay, so I anchor it outside of the graph. You can better visualize which line is which. Sorry, location equals to 2 is when bbox.anchor doesn't do anything. I mean, when you're not using bbox.anchor and you want to put it inside of your graph. And here's some more arguments for legends. And now we'll be saving your graph, which is plt.savefig cis.png, and then dpi is same thing, like how to make your graph less pixelated. You save a bigger graph. So for example, you have a graph that shows like DPI 300, but you can maybe save it as like DPI 600 because you don't want to take up too much memory of your computer. So now, okay, sorry, I'll let you guys run this as well before I move on. Okay, now on to some arguments for a line graph. So for a line graph, if you want to customize it, there's line 2D properties like marker, line style, color, marker size, label, and line width. And you can find more here at this link that I've provided. So line style looks something like this. So you've got a solid line, dash dot, dotted, or you just don't want to draw a line. So sorry. You can put these into your like plt.plot line of code so that it will give you a specific line style. And then you can add markers to your line graph as well. So these are just some examples of markers that you can add because there are many, many types. And you can click this link to find more as well. And colors. You can make your lines colorful as well. You don't have to stick to the boring old orange and blue. You want to have a pink line? You can have a pink line. You want to have a black line? Have a black line. And you can add these as arguments to your line, like plt.plot as well. And this link is for like the full, like all the colors that you can use. So I'll use the June DF to plot this line, but this will be an example line that I plotted with all the arguments. So I've set the color as pink, marker as the circle, line width as 2, line style as dashed, and then marker size is 10. And then, oh, and then here's an example of the location. So I set this as upper left, and it will put my like graphs. Sorry, it will put my legend at the upper left, but you can see it kind of obstructs. That's why I prefer putting it outside of the graph instead of inside. So this is what the line will look like. It's very, very cute. Got the dash lines, you've got the markers, and then you have the dotted line, and then the line width is 2. So this is like a fully customized graph. Yes. I'll let you guys run. I think there's a code under it that has like many, many funny arguments. I won't be going through it, but you can run it because it gives you a really strange line and it's quite colorful. So I believe you guys would have some fun running it as well. Okay. Once you guys are done with this, I will move on to scatter plots. So this will be how you plot a basic scatter plot. And it's the same as line graph with X and Y, just I've got more values here. And then, oh, sorry, the code doesn't really correspond. It wasn't meant to have these, but this is what it will look like. Basic scatter plot, just points, dots. Yeah. Do you guys run this as well before I move on? And this will be how you plot a basic scatter plot, which is plt.scatter xy color then marker. And I'll go into more detail about this in the arguments for scatter plot as well. Okay, so this is how you get your data. Same thing as just now. I've got a code for this as well, so just run this first, or else the rest of the thing won't work. So for this is a just basic scatter plot that I will be plotting with the penguins data set. So same thing as line. X is scattered. X is X value, Y is Y value. Then I'll plot the scatter of this. And then the title just gives the graphic title. plt.x label is X label, and then Y label is Y label. And so it will look like. It's very messy, but it's just a scatter plot, so yeah. Give you guys a little while to run this. And I will move on. Okay, so you look at this code, okay? Do you think it'll work? Sorry, I'll let you guys look at this for a little while more. See this code? Do you think it'll work? I'll let you guys run this as well. It's in the notebook. So I want you guys to see whether it works or not before I move on. And no, it does not work. Very unfortunate, but it doesn't work. And why it didn't work is because you're trying to plot multiple scatter plots within a single plt.scatter call by providing multiple x and y arguments. But the plt.scatter function interprets the additional arguments as marker size, styles, size, or colors. So when it sees that you've got like a data frame of like a column of things inside of marker styles, it's just going to be really confused and give you an error. And then now looking at this line of code, do you think it will work? You can run this as well. It's right under the other one, I believe. So I'll give you guys a while to run, and then I will move on. And yes, it will work. As you can see, there's 3 different scatter plots on this graph. So onto marker types. It's the same as a line in terms of like what types there are. So the link is the same, and these are the types. And then for colors, again, yes, you can have whatever color scatter plot that you want. And it's the same as the line in terms of how you add it. So like in the line, you just have colors equals to, and then whatever color you want. So rainbow scatter plots, yes. Then before I move on, if I were to run this, right, as you can see, I've got the arguments color purple, marker is this, and marker size equals to 10. Notice this line, okay? What happens when I run it? Or rather, what happens when, okay, I'll live demo this, hold on. Okay, so if I run this, right, it wouldn't work because if I write marker size will like marker size does not exist inside of like scatter plots arguments, but it exists in line graphs for some reason, so you can do that. So this is the corrected code, which is plt.scatter xy, color is purple, and marker is this. So it will give you this really silly little triangle scatter plots. Yeah. So I'll let you guys run this as well, then I'll move on. Okay, onto bar graph. So this is how you would plot a basic bar graph. This is your like labels for the graph, and then y will be the values. So plt.bar xy will basically just give you this. So you have, so A is 2, B is 4, C is 6, and D is 8. So it gives you these like values. So I use the penguins dataset to visualize. So well, this, sorry, take a look at this. Okay, do you think it'll work? Give you guys a bit of time to run it. And no, it does not work. And now look at this. Okay, now do you think it will work after I've added a dot mean? Can run this as well. And yes, it'll work. And why it works is because the number of data is the same as the number of bars, which means that there's only one value. The mean values will give one value, which is perfect for each column. So that's why the scatter plot can be plotted. Sorry, line graph. I mean bar, sorry. Okay, now onto pie chart. So this is how you would plot a basic pie chart. Okay, tells us y is your values, and then my labels is the labels. I'm on word ban, so I can't say these. But yes. And then plt.axis equal ensures that the pie chart is a perfect circle. And then plt.pie, y labels, and labels equals my labels, which is plot your pie chart. And this is what it will look like. Very, very fun. Yeah. And then using the penguins data set, just run this. This will, species counts just gives the number of like each species for better plotting, and fig size just changes the size of your figure if needed. So you plt.py this, you run this code, and you should get this. But I won't be going through pie chart in like extreme detail because it's not the most accurate of plots. I'm sure you've learned that somewhere in math before, so I'm not going through this in detail. So after you've run this, okay, I'll be moving on to subplots or axis. So there's a lot of arguments for subplots. So I'm just gonna go through the more important ones here. This will be how you set your subplot. So this is figure x, ax, and then plt.subplots, rows, columns, which is how many rows, how many columns of subplots you want to have. And then ax.plot just plots your subplot, basically. And set title, set x label, and set y label. This is a little bit different from your line graphs and all that because it's set y label instead of just dot y label. So just keep that in mind. And if the graph is a painting, figure is a canvas, and the axes are the brush strokes. So just keep this in mind as well, because this is quite a good analogy. Okay, so this will be how you plot one subplot, which is just fig ax plt.subplots 1 1, which is one column and one row, which is just one graph. This is not necessary if you only want to plot one graph, just use plt.plot or something. But for the sake of whatever, I'm showing you this. So it's just the same as like plotting a normal line graph. So I don't see why you need subplots for one like plot. Okay, then onto two subplots. I have fig ax1, ax2, which is two graphs side by side. And then plt.subplots 1, 2 is one row and two columns. So the graphs will be side by side. So this looks a little bit long, but it's not that hard to understand. So it's just ax1 and ax2, and they're separate like plots. It's just the same. It just looks really long and daunting, but don't worry about it. It's not that bad. So ax1.plot December df date and December df extent, which is plot the line graph for December, like the extent of ice in December, and then ax2.plot June df date and June df extent would just plot the June's ice extent. Yeah. And plt.show will show your separate graphs. So this is what it will look like. See, both graphs are separate, but yeah. Okay, thanks, Weezen. Okay. However, these plots are a little bit narrow, and the graphs are overlapping. Like the subtitles, the subplot titles are overlapping. So this is where fig size comes in. So when I set, like, fig size is the same as what you've learned just now in plt.plot. So fig size 15.5 will set the figure size to 15 to 5 inches, and then 15 inches by 5 inches. And then for this constraint layout, just like automatically separates your graphs so they don't overlap with each other, and you don't get the disaster of a subplot that was just now. And everything else remains exactly the same. And this is the output. So you see it looks much nicer, like much more spaced out, and they're not overlapping each other anymore, the titles at least. And the Y labels aren't overlapping. Yeah, that's how you do it. Okay. Sorry, I'll give you guys a little bit of time to run this first before I move on. Okay, so onto sharing axis. So if I want my graphs to share like an axis, or for example, I want my two graphs to share a y-axis, what I do is just share y equals to true, and then this will give me, like, this will allow both of them to share the same y-axis. So everything else remains the same, and then that's what it would get. So they're sharing the same y-axis, so that's why the second graph, like June's ice extent, does not have a label. It's because they're sharing it. And you notice it'll look a little bit different from just now, with the June DF being a little bit lower than what it was just now when the two of them weren't sharing a y-axis. So again, give you guys a little bit of time to run this, and then I will move on. Okay, so I want to save the graph. Do you remember how? So I'll launch a poll. Okay, I think. Let me see if this works. I'll launch a poll, which is Wait, give me a little bit of time to set this up. Sorry. Okay, launch this. So do you remember how to save the graph? Can y'all see the poll? Does it work? So I'll wait a little bit while the responses come in. Is it working? Yeah, I see some of you guys got tricked. Fun. Okay. I think I will reveal the answer now. So it's this. Yes, you were right. Majority of the 12, 21. Wow, okay. The 21 people that voted for POD.SafeFig, you're correct. Yes. And you can see it here. So POD.SafeFig share access dot, sorry, I forgot to add the dot .png. But yeah, you're right. Okay. So after you guys have run all of the code, hopefully you're understanding well because it's activity time. So now that you've learned Matplotlib, so here's an activity for you. I want you guys to download this data set and then unzip, sorry, not unzip it, but just download it and then upload it into your Google Colab. And for your reference, okay, I'll live demo this for you because maybe you might not know. So I will let me live demo this for you first. So what you do is yeah, thank you, Wizen. Okay. So what you do is you press you see your Google Colab. You have this thing, this file icon. You press the file icon. This is for you to upload. So I'd go to like I already have the dataset downloaded, but you go to wherever you downloaded your dataset from, and then you upload it. And I'll just launch a poll. It says like, hey, how's everyone? If everyone's done. Okay. Then if majority is done, I will move on to the activity. So to demo it again, if you missed, it's just pressing this and then finding the file and then uploading it. So I'll give you guys a little bit of time first. Okay, I'll wait for a bit more before because there's only 7 of you that says you're done. This is very concerning. Please ask for help if you need. Man, I didn't know this meeting only had 15 participants. This is so sad. Oh, sorry. What you're supposed to do is I'm just letting you guys upload the dataset first because without the dataset, you can't proceed. So I want to make sure that at least most of you have the dataset uploaded before I go on. Oh, okay. Hold on. You press this, you go to the file icon on your collab, and then you press this thing with the up arrow in it, which says like upload to session storage when you hover over it. And then there you click the dataset that you want to upload on before, and then you double click it, and then it will upload. Yeah, then you can use it. So I'll wait till like maybe half of the 83 people are done before I move on. Yeah. Thanks, guys. Please make haste. Oh yeah, while we're waiting, right, if you guys have any questions, I'll just launch a Q&A or something. No, sorry. Like if you have any question, just put it into the Q&A thing. Wait. What the heck? Sorry. I mean, if you've got any questions, right, you can just put it into the Seaborn and Matplotlib questions in the Discord. Okay, so I'll move on to the activity now. Hold on. So after you've downloaded this data set and successfully uploaded it, using what you've learned just now and with reference to the slides, I'd like you guys to plot a line graph of the resale price against the year, and then use subplots and use axes and subplots to do so. And I would like all of the four HDBs in there. And then I want you guys to plot a line graph of the floor areas of HDB flats against year on the same graph. I'd like you guys to plot a scatter graph of resale against year, resale price against year, and then a scatter graph of floor areas against year using subplots. So you've got 20 minutes. Happy plotting. There's also resources provided at the end. So like after this, sorry, like there's resources here. This is for Matplotlib summary. This is introduction, and then this is for styles. This is more arguments for arrow props, more arguments for legends, line 2D properties, markers, colors, and then these are for your reference. So you've got 20 minutes. Happy plotting. Okay, time check. Got like 7 more minutes. Can I get a rough gauge of who's done? If if you guys need help, please put it into the Q&A, like in Discord. Thanks. I mean, I'll give you guys like maybe 10 more minutes, 5 more minutes, maybe. See if you guys can get it done by then. Okay, guys, time's almost up. I think I'll just we'll move on to Seaborn now, where Weezan will be what?
Wait, Cynthia, you may want to go through like the
Oh,
answer.
oh yeah, okay. I sorry, I forgot. Okay. Let me share my. Okay, so you ran these, okay? Like I'll run these first. So this was given in your thing. So once you've run all of these, okay. For the first question, like this is what you're supposed to do. So fig, comma, ax1, ax2, ax3, ax4. I didn't really explain this, but I'm putting them in like couples because 2 2, which is two of them in here. Yeah, like two rows and two columns. So ax1, x2, x3, x4. Then the plotting is simple. It's just like this. It doesn't matter which order you put them in. Like if you put room 3 first, it doesn't matter because it will still plot. Okay, so what it looks like. I set the color to green for executive. Then I set the color to cyan for room 3. Room 4 is red. Room 5 is orange. So the output will look something like this. So I hope at least you guys would be able to get this before I move on. Okay. The output's given, by the way. I think we'll upload the answers later. Okay. So the second question, plotting a line graph of floor areas against year. On the same graph, it's just what I taught at the beginning of the workshop, like this. And then this is the labels for it, and then the legend. Sorry, I didn't explain this very clearly just now, but this is for you to add a flat type, like a title to your legend. And then for question 3, the same as question 2, but just change it to scatter and change the floor area to resale price. So this is what it will look like. And then for question 4, again, same as question 1, but just change everything to scatter and change the resale price, change the resale price into floor area. So it'll look something like this. Okay, now I'll be passing the time to Weezan for him to teach you guys Seaborn and Seaborn, sorry.
All right, guys. Can y'all hear me loud and clear? Okay. Wait, I just realized that you can't respond. But anyways, I'm just going to send out a poll first. Do y'all want a break? If so, like how long? Yeah. So I just sent out a poll. So if you, oh wow, already a lot of people are sending in 5-minute break. All right. Well, in that case, then we'll pause for a while. All right. In that case, let me just set a timer clock.app, and then I okay. Oh, need to clock. Okay. Okay, so the 5 minutes kind of starts now. Yeah. Whoa, it's a clock. Amazing. So just wait for 5 minutes. In the meantime, if you have any questions at all, be it about Matplotlib, be it about Seaborn, just go ahead, ask. In the meantime, let me just keep going. Oh, crap. Okay. Ooh. In fact, wait, just realized I might as well just play a song. Nah. Okay, so as you can see, I've already finished that song. So now it's about time that we started on Seaborn. Yep, the faster graph plotting method. And you will see very clearly why in just a minute, like literally just a minute. So here's how you import Seaborn. It's as simple as import Seaborn as SNS. Oh, wait. And yeah, SNS is just convention. It's the initials of some guy from a show. And yeah, the name just stuck. So if you want to, you can call it something else like SB. But if you go online and look at documentation, it will generally just be SNS. And without further ado, this is how you plot a graph in SNS. It's just 3 simple lines of code. I mean, 3 simple steps. In fact, for this case, it's 3 simple lines of code. So the first step would be to load your data set in a Pandas data frame. In this case, we are using the ship dataset, the Titanic dataset from the Seaborn demonstration datasets. So just so you know, this is how it looks like. This is how it's structured. And the second step is simply to just run a single function to generate the graph. So over here, you can see sns.hisplot in order to generate a histogram. And yeah, you basically just pass in the, hold on. You pass in the data set. In this case, it's ship. And then you pass in whichever columns you want to plot out. In this case, it's x equals h. So what that gives you is this beautiful histogram over here, where the x-axis is the age. Yeah. And lastly, you can use Matplotlib pyplot functions in order to do small touch-ups. Like, say, for example, without this plt.title, right? By right, you won't have any title at all. So if you want to title your graph, this is how you would do it. And if you compare and contrast, right, this is making a histogram with Matplotlib, and this is making a histogram with Seaborn. Matplotlib has slightly more code. As you can see, you need to type out the X label and the Y label for Matplotlib, which honestly looks like a lot more work. Not a lot more, but for this histogram, though, it's a lot more work for Matplotlib. But for Seaborn, it's just 2 simple lines of code. How elegant, right? And I'll explain to you what all this means just a few minutes later. But essentially, you pass in your data set over here, and then you specify, oh, I want the x-axis to be this column, but I want it to be separated into whether you are alive or not. And I want the colors to be separated on, oh, I think this is wrong. I want the colors to be, I want the colors to be separated based on my gender. Sorry, this is correct. Yeah. So just to summarize, this call thing separates whether you're alive or not into its separate columns. And this hue thing, this color thing, separates male from female into blue and orange respectively. And it's just 2 lines of code as compared to something like Matplotlib. And I'm going to be very honest with you. I use ChatGPT to make this because I'm not going to code out all this stuff when I can just settle for 2 lines of code. And now, without further ado, I'm going to start going through basically 50% of all there is to Seaborn, or the more important stuff you need to know. Firstly, I'll go through the figure level and axis level plots. Second, I'll go through how to plot out different features. And then thirdly, I'll go through how to change how Seaborn looks. All right, first part, figure and axis level plots. Now, just now when we went through subplots, I'm pretty sure that Cynthia actually, she went through figure and axis, right? So if the graph is a painting, right? If this graph over here is a painting, then the figure would be like the canvas of the painting, whereas the axes would be the brush strokes. Yeah. So to demonstrate, this whole entire image over here, you can think of it as the figure. This one graph over here is a single axis. This one graph over here is a single axis. And yeah, when you're dealing with Seaborn, you have 2 different types of functions. There's the figure level functions and the axis level functions. These functions at the top, they actually return a Matplotlib figure, whereas these functions on the bottom, they return you an axis level function. I mean, they return you a Matplotlib axis, which means that you can put it inside a subplot. So just going through all the different types of plots you can make using Seaborn. Firstly, there's the relational type of plots. These, you can think of it as relating one column, the x-axis, to another column, the y-axis, be it through a scatter plot or a line plot. Also, I won't go through into too much detail what each of these plots are, by the way. This is just a general overview as to the plots. Anyways, then there's this plot, short for distribution plot. So a disk plot basically shows you the distribution of a single column. As you can see here, the x-axis would be your column of choice, and your y-axis would be the count for each bin, or the density in the case of KDE plot. Then there is your regression plot, which is basically, in a sense, a scatter plot from relational plots, except with an emphasis on linear trends. So as you can see here, there is a straight line over here. And what this means is this is the best fit line, which is to say, this is a linear line which best explains the trend of all of the dots inside this plot. At least this is for the regression plot. I won't really explain what rested plot is, but you can think of it as how much error there is for the regression plot. Then there's your categorical plots, which is essentially okay. Then there's your categorical plots, which is a distribution for a single column. As you can see, the distribution for something like tip for each category in another column. So in this case, day has 4 categories: Thursday, Friday, Saturday, and Sunday. And basically, we show the distribution of the tip for each one of these days. This is what categorical plot is. And as you can see, there's like a lot of categorical plots. Anyways, and then last but not least, there is the matrix plots. There's a heat map, and then there's a cluster map. All right, and now to the meat and potatoes of it. This is a figure level function of a strip plot. You can basically think of each dot in a strip plot as representing a single data point. So what this means is that there is somebody who was aged 80 and lived on the Titanic, right? But then you have your axis level functions, which return an axis. And if you just go through back and forth, you realize that these functions return something which look very similar. So what exactly is the difference here? And as I mentioned before, right, the difference is that for an axis level function, you can put the axes into a subplot. As you can see over here. So I just create the histogram as usual, but I also set the AX value to be the first axis inside subplots, as you can see. And what this means is that I'm going to put the histogram at the top of my subplot. But with figure level functions, you can't really do this, and you don't really need to, because there is already some form of subplot functionality within a figure level function. As you can see here, the male and the female data are split into 2 different columns. You can do this using the call argument inside a figure level function, but not for axis level. And yeah, you can change call to row to split male and female into rows instead of columns. We'll go through this much later in like the second part of our presentation. And yeah, it's swappable, which is to say that it allows you to swap between the type of graph, like easily change between it. So right now over here, I have a strip plot, which I used a figure level function in order to show. But let's say that I wanted to also see first, second, and third quartile information instead of just seeing the clustering within each category. So what I can do is I can replace kind equals strip with kind equals box. And now I am able to see the first quartile, which is this, second quartile, which is median, which is this, and third quartile information of the categories. So just to summarize, for figure level functions, you would swap using the kind argument over here. And as for an axis level function, I would swap by changing the function itself. So in this case, I have a strip plot again, but instead of seeing the clustering, now I want to see the shape of the distributions more clearly. Like, I don't want to just know that there is a cluster here. I want to know how clustered it is. And in order to do so, what I would do is I would change strip plot into violin plot. And as you can see, I didn't really need to change any of the arguments in order to swap it. It just changes. Nice and easy. As my good friend once said, once you've learned one Seaborn plot, you've kind of learned them all. Because to be honest, the reason why Seaborn is so fast is because it's so simple. You aren't really able to do complicated stuff, but the easy stuff you do in a snap of a finger. Okay, and now for a very, very short quiz. How do you make this ECDF plot using the Titanic dataset? I'll give you guys like 1 minute to try this out inside your Colab. Okay. Wait, what? Oh my god. Okay, wait, I'm so sorry. I just realized that the code was given in the Colab. I forgot to remove it. Okay. Well, in that case, whenever this appears, right, to be honest, just try to do it in your head, I guess. Yeah, I'm so sorry. I'm so sorry. Yeah. So this is the answer. As you can see, I have an ECDF plot over here, sns.ecdf plot, in order to get this ECDF plot over here. And as you can see over here, the x-axis is fair. So in order to make the distribution that of the column fair, I would want to do x equals fair. This way, I am telling Seaborn, hey, give me a distribution of this column fair. And as you can see, this is what it does. All right. So now just a very, very short poll to check your understanding. Okay. So I want you all to just see, is SNS this plot a figure level function or an axis level function? Just answer real quickly in the poll. Okay. Well, this is slightly concerning. Okay. Well, I'll reveal the answer once it reaches 25 votes. Okay. So this is a bit embarrassing for me because yeah, SNS.displot is a figure level function. So the 11 people who voted that SNS.displot is axis level, did I teach like, is this like, am I too fast? Like, did I teach too quickly? Just checking. I teach too quickly, too fast, just nice, too slow. Okay, yeah, because like this is kind of a basic thing, and if I wasn't able to teach it properly, then there is something a bit wrong with my teaching, I think. Yeah. Okay. Too fast. Okay. Well, in that case, I will slow down for y'all. Yikes. Anyways, right. In case I go way too fast, just know that the slides are available to refer like anytime during the hackathon. I tried making it like self-sufficient such that like I don't need to present in order for you to understand it. But yeah, just so you know. Okay, well, without further ado, I'm going to try to go just a smidge slower for the next part, which is plotting different features. And this is like the most important part of Seaborn. So I'll genuinely like try to slow down a bit more because it's very important that you lock in and understand this part. Yeah. So as you can see here, I have one feature being plotted right now. I have H as the x-axis, and it's currently a histogram, right? And yeah, right now, this tells me, wow, there are like quite a few people on the Titanic who were aged 30 or so. But what if I wanted to see something else, like, oh, maybe there is a difference between the two genders. Like maybe there are older males and like younger females. Maybe there's like, maybe the males are way older than the females. And so what I could do is I could pass in hue equals sex. And what that does is that actually separates the male histogram from the female histogram. So right now, orange represents the female and blue represents the males. And now I am able to see, wow, there are a lot more males than females inside the Titanic, which sort of makes sense. But the distribution of the people on the Titanic for both males and females looks kind of the same. Like you see a peak of like you see a peak for both histograms of both colors at around the age of 25, 30. But now, what if I wanted to see, oh, what's the difference in distribution between those who died in the Titanic and those who survived the Titanic? So what I would do is I would have call equals alive, which is to say, I want to split whether you're alive or not into two separate columns. And so now the left column is for people who are not alive, and the right column is for people who are alive. And now you can see another pattern, which is, wow, there are significantly more people who are female who are alive. But if you aren't alive, then yeah, you're more likely to be male. And so like we are able to split up our data into our different columns in order to sort of elucidate, in order to understand our data a bit better. This is all just to say, pass in columns as arguments in order to highlight them. So as you can see over here, I'm passing in the column alive in order to highlight the fact that, oh, the distributions for people who are dead is different from those who are alive. And now you may ask, what exactly are the features which I can like plot out using like different columns? And yeah, here are all the features for this plot. There is X and Y. There is hue, which means color. There's row and there's column. And yeah, when you think about it, it doesn't really make sense to have a y-axis for a histogram. So, okay, I'll just reveal it. When you actually put in an x and a y axis, right, you get something which sort of looks like a heat map, but without a legend. So perhaps this is why there is no figure level function for matrix plots. Yeah. Given that the Colab already probably has the answer for this, I'll just go through how I would approach making this particular plot. So first of all, you notice that, okay, these are dots, which means that it's probably a scatter plot, which means, yeah, I would want to use the relational plot. I would want to use rel plots. And then I see, okay, there is a row. There are different rows for whether or not you are alive. And you have different columns on whether or not you are male or female. And I have different colors based on whether I am first class, second class, or third class. And so that would mean, okay, I want to plot out the hue, row, and column features using the respective columns. And yeah, the answer would be something like this. I think it's inside the Colab. So as you can see over here, right, my x-axis is age. My y-axis is fair. And my hue, which means color, is class. My column over here, which is like separated between male and female, would thus be defined as like call equals gender. And then there's row, which is whether or not you are alive. So I would put row equals alive. Yeah. I hope that broke it down for you, and now you're able to understand how to plot out these different features using like different columns. And yeah, now I'll just go through the fact that the features you can plot out inside relational plots are actually different from these plots. Like over here, it looks a lot less than this. And yeah, you are able to actually plot out something else like style. So like, let's say that I wanted to, like, instead of class being hue, I wanted to make it style. What that would do would be something like first class would be a square represented by a square. Second class would be represented by something like a triangle. And third class would be represented by something like a circle. Okay, that's a really ugly circle. Yeah, a circle. And then there's also size, where you can pass in like some other column, like say for example, how old they are. So if I put something like, no, just have pen. If I put something like size equals to the age, then what I would get would be, if you are older, then this circle would be bigger. Old. But if I were younger, then this circle would be smaller. Young. 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 Yeah. And then there's also weights and units, but I won't go through what that is. Yeah. Hold on. Then there's cat plot. Yeah, it's less, so you can only plot out X, Y, hue, row column. Same thing for your LM plot or your regression plots. And yeah, this is like basically the gist of the most important part of Seaborn, which is how you can use different features of your graph in a figure level plot in order to show like different parts of your column, in order to highlight different columns in your data set. Sorry. All right. And yeah, as you can see now, the slides are blue instead of red, which means that, yeah, you can like sort of stop paying attention, but also don't, because this is still good to know. So right now I have a linear regression plot. I have a reg plot, and it's looking kind of messy. Like over here, I just have a big chunk of blue, but I'm not able to see how clustered it is. Like this cluster of blue looks the same as this cluster of blue over here. And so one solution to this would be to reduce the opacity or increase the transparency of each one of these dots. And how I could do that is using, well, scatter keywords. Because Seaborn uses Matplotlib figures and axes at the end of the day. At the end of the day, it returns something from Matplotlib. So what I can do is I can pass in scatter keywords, which basically takes in the arguments for plt.scatter and passes them into the plt.scatter, which is being used under the hood. And as you can see now, it still looks kind of messy, but it's a bit easier to see that there are like clusters in this line over here, and there's clusters in this line over here. Yeah, so it's more visible. Same thing for line keywords. Basically, line keywords takes in arguments for plt.plot. And so if I do color and then a colon and then G, that's effectively the same as like under the hood passing in color equals green for plt.plot. But yeah, if you want to know what things you can pass in as scatter or line keywords, you can just look at the documentation for plt.plot and plt.scatter respectively. Although, and I don't know whether I'm allowed to say this, but it should be easier if you just chat GPT it. Like honestly, I wouldn't waste my time like memorizing these things or like even studying it, because this isn't the important part. The previous part about plotting different features with different columns is the important part. This is just sort of aesthetic. And now, what if I wanted to sort of annotate my scatter plot? I think Cynthia went through a bit of plt.annotate, and now I can actually show you another way to annotate it. Like over here, I actually calculated the R² value of this line. What that means isn't really that important. All you need to know is that the higher the R² value, so the closer this value is to 1, the more the points inside this graph, like the more these points, can be explained by this line over here, by the best fit line. And yeah, if I wanted to put the R² value next to the line, then what I can do is, after doing my SNS function, in this case sns.lmplot, I can simply just do plt.text in order to put in whatever text I want. Yeah. As you can see here, yeah, the matplotlib text functions are actually integrated with the Seaborn functions, because at the end of the day, Seaborn uses matplotlib under the hood. All right. And now I'm going to teach you how to stack plots on top of one another. Like, let's say that you wanted to not just have this plot, this regression plot, but you also wanted to see the distribution of the dots themselves. So what I could do is, on top of this regression plot, I can also put a histogram. So first I do sns.lmplot over here, and then I do sns.hisplot, one after the another, and they stack on top of each other. But I just have to warn you, this does not look that nice. There is actually a better way to do this, which I'll show you later. It's called, okay, you'll see later. It's called joint plot, I think. But just a word of caution, do not put the figure level below the axis level. So right now, we can tell that this is a figure level function, and this is an axis level function. So the figure level is actually above the axis level. Now, if I actually swap this, as you can see over here, if I swap this, you're going to get two separate images, okay, of like one histogram and one LM plot. You're not going to combine them. Yeah. Anyways. Then there's pair plot, which basically means, okay, I am now able to see all the relationships between all the numerical columns. So like from this pair plot alone, I'm able to see, wow, there's like sort of a linear trend for flipper length versus body mass. And I can see a lot of clustering for like build depth and body mass, like this cluster over here and this cluster over there, something like that. So just to summarize, pair plot allows you to summarize all these relationships. You're able to see at a glance these relationships. And now I'm going to teach you how to customize it. So now I made it more colorful by passing in hue equals species. Wow. So now I'm able to split up and show different species with different colors. As you can see over here, blue corresponds to Adelie, orange corresponds to Chinstrap, green corresponds to Gentoo. And you're just not able to see that kind of information from this homogeneously blue graph. And yeah, other than hue though, there are like 3 other different ways to change the pair plot. There's kind, which changes the plot type for everything except for the diagonal. So I'm able to change the plot type for this part and this part over here. There's diag kind, which changes the plot type for only diagonal. So I'm only going to change the plot type for this. And then there's corner, which only shows the bottom left corner and basically yeets away this part of the graph if it's set to true. And how does it look like? Well, I'll show you now. So I now change kind equals to reg. And you can see now that all of these are regression plots. You can see a line for every single one of the graphs except for the diagonal. And here are all the different types of kinds of graphs you can change it to. Same thing for diagonal kind, as you can see over here. And corner equals true, corner equals false. There's only 2 values you can have for that. Next, join plot. Remember just now how I showed you how you can like stack plots on top of each other? Remember this? Well, this is somewhat a prettier version of that. Because now instead of the histogram directly overlapping with my scatter plot or my regression plot, I'm able to just see the scatter plot clearly and have the distribution on the side. And what this means essentially is I get to show the scatter plot of body mass versus flipper length, while also showing the distribution of body mass and the distribution of flipper length. Yeah. And yeah, there's basically only one argument which you can change for this, which is kind. Kind equals KDE, changes it to a KDE plot, then a scatter, hist, hex, reg, and rest it. Okay. And now we've reached the 3rd part of our lesson. But before that, let me try to cook up a question real quick. KDE can tell what kind of. Oh, a KDE is distribution. So it allows you to see the distribution of the plot. It's sort of like a histogram, but you smooth it out. Yeah. But anyways, okay. I have no question for y'all, but do y'all want like a 1-minute break? Like, is this a lot to digest for y'all? No. Okay, this is hard because now the poll is like evenly split between yes and no. But okay, you know what? I'll just give you like 30 seconds. If you want to, just look through the slides, digest it, and if you need to ask for any help or you want to ask any questions, go ahead and ask inside the Discord. Okay. Well, now I'll move on to looks. And I promise this will be rather light compared to the rest of the slides. Because to be honest, you don't really need to know this. It's just good to know. So right now we have Seaborn graphs, but they look like Matplotlib. They look kind of boring, right? Well, with one simple line of code, I'm able to make it look just slightly better. Yeah. And yeah, SNS.setTheme, in essence, allows you to change how your graph looks. There's 5 different ways you can change how your graph looks. There's context, which is how big the entire graph is. There's style, which allows you to change the color of the axes. There's palette, which changes the color for color maps. There's font, which changes the font family. And then there's font scale, which changes how big the font is. And in case this is kind of abstract for you, don't worry, I'm going to go through what exactly these all mean right now, actually. So first, context. If I wanted to say put context equals poster, then what I would get is I would make the graph look really, really big, as you can see over here. Like before, after. So you can play around with these if you like. But basically, poster is the biggest. By default, it is... I'm not too sure what the default is, but by default, it's definitely smaller than poster and talk. I don't remember whether it's paper or notebook, but then there's style, which basically changes the color for the axes and the grid. So in this case, right now, the default when you do SNS.setTheme would be dark grid. As you can see, these gaps look kind of dark, right? They look darker compared to the white over here. Well, if I change it to white grid instead, then now the grid itself is white. It's the same color as the background. Then there's palette. I think Cindy gone through a bit about color maps just now and colors. But basically, this allows you to change the color for your points and like your line. So if I set palette equals dark, then I would get, darker points. Then there's font. I would advise you not to touch this unless you genuinely have a good reason to do so, because, like, not gonna lie, if you just put any whatever font like Comic Sans, it would just look kind of ugly, right? So don't just randomly place whatever font you like, because more often than not, that may actually make you have an uglier graph at the end of the day. And then there's font scale, which changes the font size. So if I set font scale equals 2, as you can see, now the font size is like twice as big. And yeah, this begs the question, what's the difference between font scale and context? Which is that, yeah, font scale only scales the text, whereas context scales up everything. It scales up the grid, scales up the lines, scales up the points, whereas that doesn't happen for font scale. Context scales up everything. Font scale only scales up the font. And yeah, that's basically about it for what I have to teach. We're going to go through 1 or 2 exercises later, but here are just some other things you could learn, but you don't really need to, because it's lower level stuff. So there's facet grid, which is basically the backbone of all the figure level functions, which is more DIY, but more customizable. Pair grid, which is basically the same as facet grid, but instead of figure level functions, it's pair plot. And there's Seaborn objects, which allows you to make Seaborn style plots with Matplotlib like DIY-ness and somewhat Matplotlib like functions. You'll have to see it for yourself, but I won't go through it because you don't need to, and it will take a long time. And also, one thing which you might have noticed is that there are no pie or donut charts in Seaborn, so you have to do this in Matplotlib. So sad. And now, just a brief summary of everything we learned in Seaborn. So we learned figure level and axis level functions, which is like this top thing is figure level, whereas this bottom thing is axis level. You have like the different ways to plot out different features using your figure level functions over here. You have your pair plot, which summarizes all your relationships. You have your joint plot, which shows both the relationship in the form of a scatter plot and distribution in the form of a histogram. And then you have SNS.setTheme, which essentially changes the way your plot looks. And yeah, that's about it from the tutorial. Don't leave yet because we still have like a few things to do. But in case you want more information, you can refer to these two things, the tutorial and the API reference for Seaborn. We basically covered like 50% of the full tutorial, which is the important stuff, that is. But we tried to make it easier to understand. Hopefully that came across. Anyways, now on to an assignment. So the thing is that our assignment was supposed to be something like, find me some interesting relationships for HDB flats resold after 2017. But this sort of overlaps with the previous activity, so I'll just walk you through this. If I were to do this from scratch, what I would first do is I would go on data.gov.sg and search up for the dataset which I want. In this case, the dataset is over here, this link over here. You can click it on your local copy. And after that, I would use something like sns.hairplot to find interesting correlations. And yeah, without further ado, I'll just like walk you through this. Because honestly, there isn't really much of a point if I like ask you to do it, because you already did some of it just now. So let me just change the screen which I'm presenting. Okay, so in essence, right, first thing I do is it show? Oh no, it doesn't. So the first thing I would do would be to it would be to obtain the data from the data.gov.sg website, right? And in essence, how that would look like is, yeah, I would start off from data.gov.sg and I would search up resale flat 2017 or something. Oh. Now, this isn't the exact thing which I wanted, but I hope this illustrates to you basically what I would do. Okay, now this is what I wanted. Resale flat prices based on registration date from January 2017 onwards. So I would go to this data set, I would download the CSV, and after that, what I would do is I would, hold on, let me just swap back to the Colab. After that, I would just, in essence, hold on, let me just, I would load the CSV over here. Resale equals blah, 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 blah. And so this is how your data should look like. And if I wanted to have a more general overview of not just the columns, but also the different data types of each column, then I would do resale.info. I'm not too sure whether they taught you this in the Pandas class, but if they didn't, this is really good to know, because then you're able to see all the columns at a glance. And first things first, you want to do some basic cleaning steps, like dropping all the rows with any values. And next, something which you could notice is, oh, there are numerical values over here for story range, and yet story range is actually an object data type. And then there's something like month, which should be date time data type. But instead of that, it's object data type. So as part of my cleaning step, something I could do would be to split the story range into the start story and the end story. Oh, someone raised their hand. Oh no, I didn't raise their hand. Whatever. So I would split it into the start story and the end story. And I would convert this month into a date over here. And as you can see now, I have my month, which is in like a more proper date time format. And I have first story as a number and last story as a number. And because now I have these data inside the proper data type, I'm now able to do my analysis more properly. So first thing I could do would be something like a pair plot in order to see any trends in the data. And as you can see, right, except for first story, last story, which is sort of a scam, because like it's too straight, and I hope that you understand why it's basically a straight line. Except for that, the only sort of linear-ish data would be the resale price. Like if you squint, you can sort of see like how you could draw a best fit line here, but well, we can investigate it, that is. And when we use a regression plot on our resale price data, and we also put the R-squared value, we can see not just from the very low R-squared value, but also from this line just not matching this blue data points. We can see that, honestly, this is not a linear trend, and we most likely need something else, like maybe a quadratic equation to describe it. And now we could investigate something else, like how does the type of flat change with the resale price? And what I could do is I could use a violin plot in order to see, oh, so this is how each one of the flat types are distributed. And from here, you can actually see some sort of obvious, but also illuminating trends, which is that, see this white line at every single one of the violin plots? This white line it represents the median resale price of each one of the categories. And as you can see, right, it sort of goes up the bigger it is. But yeah, that's sort of obvious. Of course, you have a bigger room, it sells for a higher price. But what I find more interesting is that, to be honest, a 3-room flat has a very, very wide distribution. Like very, very wide. As you can see, it is very right skewed, which is to say that there are a lot of there are a lot of 3-room flats with exorbitantly high prices over here. Whereas if you look at some bigger flat, like a multi-generation flat, the prices, yeah, on the median price for a multi-generation flat is lower than that of a 3-room flat. But the spread is also smaller. And yeah, we don't know why this is, but this fact alone is actually pretty interesting to me. Anyways, one last thing which I was curious about is, hey, like maybe I heard that before BTO flats, it was like super cheap, like all the resale flats were like cheaper, but now it's more expensive, something like that. Or, oh, maybe the current ongoing wars or like current geopolitical landscape is causing a lot of economic uncertainty, and that maybe might have caused the prices to increase, the resale prices of flats to increase. And so what I could do is for each month in our data set, we could find the average resale price using group by. I don't know whether they taught you this in Pandas, but we can find the average resale price in each month and plot it over time. And as you can see, there's a very drastic spike starting from 2020. And you know what happened in 2020? COVID. So yeah, one thing which you need to know is that correlation doesn't necessarily mean causation, which is to say that just because 2020 was the year of COVID and prices spiked in 2020, it doesn't mean that COVID caused this spike, though I presume that it did. But you know how in primary or secondary school you learned that this is also kind of misleading, right? Because the limit doesn't start from 0. This limit doesn't start from 0. In fact, it starts from something like 40,000 and something. So what you could do is you could make it less misleading by setting the y limit to 0 over here. And as you can see now, it looks way less drastic. It just looks like a slight increase, but an increase nonetheless. And yeah, by looking at this graph, you can tell that there is an increase. But what if I wanted to find out, what exactly is this increase? What percentage is this increase? So what I could do is, yeah, I manually use Python functions, Pandas functions, and find the percentage increase. And we find that it's actually 38% higher. That in 2024, this average resale price is 38% higher than in 2017, which is quite a lot if you ask me. Anyways, I'm going to give you, oh shoot, wrong thing. What do I, oh gosh. I'm going to give you an option now. Like, I have this optional activity where we were to analyze trends in cosmetics with hazardous chemicals reported to California, right? And I know that right now it's 12:40, which means that there is like 20 more minutes. So do you want me to like live demo this, or would you rather have me like just explain the thought process? Because like right now we are kind of constrained by time. Okay. So I see here that there are 12 votes for live demo and 8 votes for explain verbally. And not gonna lie, I'm actually kind of nervous because I only planned out this activity in my head. I didn't code it out because I wanted to like simulate how this activity would actually be for an actual participant. But yeah, I guess I could live demo it. But first, I need to explain to you like, yeah, how do I find data? And generally, you can just search online. And it's really important that you learn how to find data because not just in the hackathon, but also if you decide to do data analysis in the future, you'll need to find the data yourself. You're not going to have somebody spoon feed you the data. And yeah, without further ado, I'll just say, this is where I would find the data because I know that United States data would generally be in data.gov. So I could just open up. Something went wrong. Hey, why can't I present something else? Okay, this is technical difficulties. Okay, so this is the data set which I am going to use, right? And generally, how I would do it is I would search something like chemical California. And as you can see, it's like the first search result you get. Then you go in here, you download it. And once you download it and put it inside your thing, right? Okay. This is slightly problematic because now I need to show my full screen. So now that I downloaded my data set over here, it's inside Cali Chemical. What I would first do would be to do all the necessary imports. So import Numpy as NP, import Pandas as PD. I have 15 minutes, so I need to hurry. Import Seaborn as SNS, import Matplotlib.pyplot as PLT. All right. And now, first things first, you want to load in the data, right? So data is equal to pd.readcsv. And what this does is it allows me to read all the data inside this data set. And yeah, what I would do is I could like look at the structure of the data by first doing data.hit to see the first 5 values of the data set. And I could do data.info in order to see the structure and the data type of each column. And over here, I actually wrote down a few things which I would have wanted to do. I'll just write it down over here. So the first thing I would want to do is find the proportion of chemicals. Second would be the initial reports in each month over time. Second would be final report for time and top 5 companies / chemicals and compare the companies average. So these are the things which I thought of in advance because like, yeah, I just thought of it like, yeah, look, there's so many like chemicals, right? There's so many chemicals. But which one is the most like, which one is the one which appears the most? And okay, then there's initial date reported. I wonder whether there is any trend to this initial date reported, or like the clustering of initial date reported. Then there's top 5 companies. So like, which one of these companies would be the biggest offenders of like using chemicals in their products? And then out of one of these, I just compare it. So I think we only have time for one of these. So let's just live demo proportion chemicals. So what I would want to do is I want to isolate this chemical name over here. So data, this is the name. So first of all, I want to isolate this. And actually, I want to find the counts of each one of this. And what I could do is I could use this thing called value counts, which in essence breaks down all of these for me. But if I were to make a Matplotlib pie chart right now, it would look kind of ugly, right? This is not ideal. And I'm not able to see like this over here. Like I'm not able to see these chemicals squeezed all over. Shucks. I'm not able to see that like the chemicals with like 0.1% of stuff, I'm not able to see it. So what I could do is for all the, I could take all of the, I can take all of the things which are not in the top 5, and I can sum it up in order to get this lump sum of 12,000. And I can concatenate it. Yeah, so I can take my value counts and I concatenate it. I'm actually like kind of stressed out right now because this is the first time I'm actually live demonstrating anything for y'all. So if something goes wrong, I'm so sorry. Okay. Well, it's not really working. So I don't think I can do this right now under such time pressure. So I'm so sorry, guys. Yeah. It's not about the titanium dioxide. No, like the whole point of me trying to do this is that I wanted to like show you, oh, there is like this titanium dioxide, there's coal tar, and then there's all the others. But usually what I would do is I would spend a lot more time like debugging it. So I'm so sorry that I wasn't able to do a live demonstration properly. Yeah. I think that is about it, but there are still some closing statements which I would like to share with y'all. Okay. So right now, all you know is Matplotlib and Seaborn have graphs. But did you know that Matplotlib can actually do animations? And then there's also stuff like location type data with Plotly and Folium. Like you don't know how to do plotting out based on location for Matplotlib and Seaborn, right? And then what if I wanted to show all my data inside a website? So you could use something like Dash or Streamlit for these data apps. But these things aren't just within Matplotlib and Seaborn, or at least what we taught you just now. So what I'm trying to say here is that there is a lot more to data science than just these two. Than just Matplotlib and Seaborn. So I really encourage you to really just try out the exercises just now, especially this one, and just get a grip of how Matplotlib and Seaborn works first. But then after that, do understand that this is just the beginning. Like, this is like the tip of the iceberg on the data science iceberg. And I really hope that you can like really dive deeper into this after this lesson. Anyways, here's a feedback form which I'd like y'all to fill in. I think that is about it. Cynthia, you have anything else to add?
Nope.
Okay. Well, in that case, after you've filled...
Wait. Someone raised their hand. Was it on accident?
I mean, like, if they raise their hand, it's not like we're able to address them if they
True.
didn't answer inside the... And if they didn't ask their question
You
inside
got questions?
the Discord.
You put it in the Discord. Okay, you can continue. I don't have anything else.
Yeah, so there isn't really that much else. So yeah, thanks. This is over. This lesson is over, but yeah, just fill in this feedback form before you leave. Yeah. Thank you so much.